So good morning, ladies and gentlemen. We're going to look at, again, review of quadratic functions, all types, the PDF, example 4. This one's a little bit more interesting. It's written as y equals 3x minus half x squared minus 5. And I think everyone here in class today, cohort B, realized the trick for this one, put it in standard form. This is trying to trick you, but put it in standard form first of all. So y equals negative half x squared plus 3x minus 5. And for question A that they're asking you to do is complete the square. So in this case, can I get a volunteer from the class to help us out? What should we do first? You can just give us the next line and you can do cheaper. Tanesh, you want to help us out? Alright. So what would go here?
That would give you negative 1.5 for
40 is incorrect. Nice try though. It's okay, don't worry, we'll talk about it more. Aruna?
It would be negative 6.
Negative 6x is correct. Yeah, it's okay, don't worry. And that's what the tricky part is, right? When the a value, ladies and gentlemen, is a fraction, and we can definitely check with expand. Oh, that's okay. This is why. So negative half x times x squared is negative half x squared, and negative half times negative 6x is positive 3. And when you actually expand, it's okay, right? So that's the tricky part for this one, right? So let's speed this up though. What's going to be the next line? See if someone actually can give me this. All three things. And again, you don't have to do the intermediate step if you don't want to. Ted, one.
Oh, x minus 3.
minus 9.
Before we continue, everyone okay? How you got that so fast? If you're not too sure, I'm going to insert it right in between. We got y equals negative half x squared minus 6x. We don't know what that is. Minus 5. And so take that new b, which is negative 6, divide by 2, which is minus 3, and then negative 3, and you square it is equal to 9. And so just to emphasize this in red, you get the plus 9 and then minus 9 here. And that's why Ted gave us that x minus 3 all squared, because that's the answer to that second step, and that minus sign is this value. So I'm just trying to show you. A lot of students actually skip this step, but it's actually the essence why this is called completing the square, because this perfect square, which is expanded, needs to be factored. And that's why doing this rough work here off to the side is very, very useful. In fact, it works especially in our example 3 on that sheet that we gave you. But we still have to clear those square brackets. And again, notice it doesn't influence the rounded brackets here. So negative half times negative 9 is positive 9 over 2. Okay. That's fine. And I think our final answer is, I think that's negative 10, so negative a half. So double check the math. Thank you. And so for part B, it says determine the roots by isolating x from vertex form. So don't get me wrong, we can definitely use quadratic formula if you want, but they're asking you to practice with vertex form. So one more time for question B. Oh, and just to pause for a second really quickly. Why we're doing this, just to talk about it, it's related to, I don't have it here. It's related to the perfect square pattern, right? So some of you don't want to know why. That's C term, which has been squared. That's this portion. And the 2 is related to that opposite of this is multiplication. And when you take out the a value, although it's 2ab for the perfect square, since it's one of the values, so all I have to do is deal with that 2, which is the division by 2. That's actually why you're doing this. So this algorithm. Notice you have to divide first before you square. If you square first then divide, you're going to get the wrong answer, right? So that's why the order actually matters. Back to this, question B. So I think they're asking you to do it this way. Let y equal 0, so 0 is equal to negative half, assuming you got this correct, which I have here, and hopefully I'm still on screen. I am over, but that's okay. Can I get a differential to help us out? What should be the next line? We're working with radicals. And Tanush and Jasmine's been helping us out really well. Any volunteer? No one want to help us out?
You would add 1 over 2 to both sides.
Sure, so we get a half is equal to negative 1 over 2 x minus 3 squared. Nicely done. Do you want to keep on going now? Is that alright?
So then you would divide both sides by negative 1 over 2.
Sure, I would do that too. Again, notice he's trying to get rid of the negative half. And if you divide both sides by negative half, you're going to get negative 1 is equal to x minus 6 squared.
Should I keep going?
Sure, why not?
So then you would square root both sides.
Square both sides is correct.
And then some,
I'll do the easy side though, is that okay? What's on the left hand side?
so just negative square root of negative 1.
Square root of negative, or we actually now, because we did a test on this,
So that's I.
it is odd. So notice, there would have to be a disclaimer here. That's why, sorry, we should say where x belongs to the complex number system, but that is correct, that's gonna be I. But more importantly, plus or minus I. So just be careful with that, that's the only mistake I think a lot of students do. They get, yeah, negative I, this is I, but when solving, you get not 1 but 2 x. And that's why a lot of you realize, when we're doing the complex numbers, is conjugates, one's added and one's subtracted. So want to finish it off?
Yeah, so then you could just add 3 to both sides to get, then you could add 3 to both sides to get rid of the 3, so it'd be x equals 3 plus minus I.
Nice. And it's telling us that the roots, or the zeros, or x-intercepts, they're complex. Right, so you can't really graph them. Okay. And just to help some people out with the mapping technique for question C, I'll just give you the answer. X comma y, after x plus 3, and then negative half y, minus a half. And if you those want to finish off that table, and I apologize, I will move this just slightly over. So people can see. So question C as well. For the new transformations, if I follow this information, you're going to get these values. So 1, 2, 3, 4, 5. And that's going to be negative 2.5, negative 1, negative 0.5. And I'm just using pencils. And negative 2.5. And a lot of you realize if you were to do a sketch of this parabola, it's going to be at 3. This projection would be 3 is over there, and negative half is here. Like that. Like something like that. This is the one. Something like that. And the parabola doesn't cross the x-axis. It's complex. Does that help? Doing example 4?